Alright, this is the end of chapter 11, which deals with the properties and reactions with the halogen group, which is group 7 on the periodic table. Here is the quantum shells of the halogens, just like we did for the alkali earth metals. They all are similar in shells, meaning that they're almost full with 7 electrons, with 5 being in the p, a full s with 2 electrons. This is why they're so reactive, because it only needs one more electron to be full, stable. Obviously, you can see they are increasing in size because you have different energy levels from 2, 3, 4, 5, and so on. Fluorine being the most reactive because of that smaller radius, and iodine being the less reactive because of the larger radius. All nonmetals, with them all being diatomic, meaning there's a single covalent bond between the two atoms, making 2-atom molecule. Here's your radius chart. Obviously, you can see them increasing as you go down the periodic table, with iodine being the largest. Sorry, ST. Alright, melting points and boiling points. Obviously, they're going up to their melting points and boiling points, fluorine being and chlorine being a gas. Bromine is a very volatile liquid, and then iodine is a solid. Alright, reactions with the halogens. Reactions with metals, they make a ionic solid when you're dealing with a metal. It could be alkali earth or alkali metals or even transition metals. They are a reduction, meaning they gain electrons. That makes sense because they are only needing one electron to be full. And reaction with hydrogen makes an acidic gas, which later on can be made into an acid with bubbling through water. Chlorine is a very strong oxidizing agent, like most other halogens. Alright, electronegativity. You can see as you go down the group, reactivity goes down. That is because of their size. Fluorine is a very tight atom radius, so they are more reactive. And you can see that with the electronegativity also going down, meaning not as reactive. Again, as you go down to group 2, the oxidation power does decrease, meaning fluorine and chlorine are the stronger oxidizing agents, meaning they reduce quicker than bromine and iodine. Alright, more reactive halogens will replace a less reactive halogen from a halide solution of the less reactive halogen. Basically, it's a single replacement reaction, and the single lady always needs to be the more reactive one to displace the other halogen. So for example, chlorine is more reactive than bromine, so when it reacts with sodium bromide, the chlorine kicks out bromine, and then you're left bromine by itself. There's a net ionic reaction. Basically, sodium is a spectator ion, so get kicked out and just watch. If the opposite is true, bromine with sodium chloride, nothing will occur because bromine is less reactive than chlorine, so nothing will happen. NR. Here is some pictures of different types of halogens with cyclohexane. Iodine would give you a purple color, bromine more of an orange color, and chlorine is a very pale green, yellow color. Alright, reactions with hydrogen. So you make a hydrogen halide vapor, gas. the reactivity does go down. You can see that HI is at equilibrium. And you can see HF is a very explosive reaction, just like with chlorine, and then it starts slowly, and then at equilibrium with iodine. Thermostability, the most stable molecule is HI, and goes down, it gets less stable. That's because the bond between H and I is not as strong as HF. As you go down the group, the bond energy also decreases, so you can see why the energy is needed to be less for HI compared to HF. HF has a bond energy of 560 compared to 300 HI, so it takes a little less energy to break this HI bond than the 560 of HF. Again, that's deal with the size of the bond compared to the size of the iodine and fluorine. Iodine is a lot larger molecule, so that bond is weaker compared to the HF bond. Alright, reaction of the halogen halide ions. So you can dissolve a hydrogen halide with nitric acid, and you can precipitate that out with silver nitrate, because the silver will react with any of the halides to give you a solid, like silver chloride or silver bromide, silver iodine. The cool thing about silver, it does form 3 different distinct precipitations. Chloride is this typical white one. Bromine's a little dirtier with cream color, and then a yellow color for iodine. And then you can see also how other reactions will occur to determine which halide you have. So a dilute solution of ammonia will only dissolve hydrogen chloride, or silver chloride, sorry. A concentrated solution will dissolve both the silver chloride and silver bromide, but then the silver iodine will still remain insoluble. So it's a good way to determine different halides. So by color and then other reactions. Alright, the last one is a disproportionation reaction. Basically, it just means it's a self-reduction oxidation reaction, meaning one substance is being oxidized and reduced at the same time. Crazy! One thing cool about this reaction, it does depend on temperature. Chlorine in a cold alkali solution, sodium hydroxide, whatever, calcium hydroxide, will produce a salt, and then particularly more important, the sodium chlorate or hypochlorate, or the sodium chlorate 1. You can see here chlorine goes from 0 to -1 with the NaCl, so that is being reduced. But in the sodium hypochlorite, or the sodium chlorate 1, or I, it goes to +1. That's why it's I. So it's also, that's being reduced, oxidized. So it is a self-reduction oxidation reaction. It goes from 0 to -1 and 0 to +1. In a hot alkali solution, or sodium hydroxide solution, it does react further, meaning that the sodium chlorate goes from a 1 to a 5. So the chlorine is still being reduced with the NaCl, 0 to -1, but chlorine is also being oxidized further to a 0 to +5. So this is sodium chlorate V, or sodium chlorate 5, as your product instead of sodium chlorate 1. So the hotter it is, the further reaction goes, which makes sense. So an element can act as oxidizing agent and reducing agent if oxidation numbers both get reduced and increased. Alright, here are your 4 homework questions dealing with the volatility of a halogen group. So what happens to the volatility as you go down? Acetine lies below iodine at the bottom of group 7, so predict its states at 20 degrees, the color, atomic radius, and vigor of its reaction with hydrogen. Write a balanced reaction between chlorine and water mixed with potassium iodide with states, and write the net ionic reaction of chlorine and hot